Hi, in this video, I'm going to walk you through linear graphs. And since I just mentioned the word graphs, it is paramount that I talk a little bit about the Cartesian plane, since our graphs will be existing or they will be living on the Cartesian plane. And a Cartesian plane is simply a gridded space that looks like this. And on this space we can put reference lines that are horizontal and vertical, and where these lines meet we call that the origin, and these lines will have numbers, and I'm going to show you the actual numbering of these lines in a moment, but for now I'm just walking you through the introduction. And these lines have names. The first line that is horizontal is called the x-axis, and the second line that is vertical is called the y-axis. And this space is what we call the Cartesian plane, a gridded space with reference lines, the x-axis and the y-axis. And on this space we can put many lines, and that's where linear graphs are coming from. These are straight lines that are on a Cartesian plane, and these lines can either be horizontal like this, which can be pretty much positioned anywhere in the plane like here or even here, or these lines can even be vertical, which can also be placed anywhere in the line like here or even here. They can even be diagonal of any orientation like this, which can also be placed anywhere in the plane like here or here, or they can even have a different direction altogether like this, which can also be placed anywhere on the plane like here or even here. But as you can already see, we have this line that is actually being rotated in the plane like this, and this, and this, and this. But in other words, the orientation and the position of this line will be governed by an equation, which is this. And y is equals to mx plus c is what we're going to dissect right now. But before we do, let's talk about something very important in a second, which I want you to be able to do by the end of this video. This is how the actual Cartesian plane will look like. You can see the swirls or the grids that we're talking about, and you can also see the reference line, which we called the x-axis, and this vertical line, which we called the y-axis. And remember, where they meet we called it the origin. And something that you can already see is from the origin going in the horizontal line to my right, the numbers are increasing in size. We have 1, 2, 3, 4, 5, 6, 7, and to infinity. And as we go to my left on the horizontal space, you can also see that these numbers, they are becoming quite small. And this is true also for my y-axis. But this will be the actual numbered Cartesian plane where we are able to do our linear graphing. And I will just show you at least the basic linear graphs that you're supposed to know before we get them to be complicated. It is expected of you that you're at least able to draw basic horizontal and vertical lines on your Cartesian plane. To begin with, I'll go to y and draw a line in y at exactly 2. And as you can see, GeoGebra was smart enough to go in the y-axis and drew a horizontal line at y is equal to 2. If you don't have this application with you, which will be the most likely case when you'll be writing your exam or your test, you will simply go in the y-axis and draw a horizontal line at 2. Also, we can even draw another line at y is equals to perhaps -1. And as you can see, I have the horizontal line at y is equals to -1. We can also draw lines at y is equal to perhaps a -3. And as you can see, respectively, the GeoGebra application drew for me the line or the horizontal line at -3 in the y-axis. Similarly, we can also draw vertical lines even in the x-axis. For instance, when I go in the x-axis and I go exactly at -2, you can see that I have my vertical line in the x-axis at exactly -2. And I can also have it any way I want in the x-axis. For instance, when I have x is equals to perhaps a 3, you can see that I have also a vertical line at x is equals to 3. I can even have a vertical line at x is equals to 0. And as you can see, there I have the line. And let me draw it one more time, since the color is a little bit very difficult to observe. But there you go, you can see the line at x is equals to 0, meaning that you can draw these on your Cartesian plane. Now it is your turn. I'm going to remove all these lines. I'll be giving out the equation and you're supposed to indicate in your head where these lines are going to be. And our first line is going to be y is equal to 3. Where do you think y is equal to 3 is going to be? Right here. Did you get it correct? Let me know in the comment section. Let's have another one. We have y is equal to -4. Where do you think y is equal to -4 is going to be? There we go. Did you get it correct? Also let me know in the comment section. And let's do the last one. Y is equal to 0. Where do you think y is equal to 0 is going to be? Did you just say right here? If you did, congratulations. Let's do one more time for the x-axis. Let's say if x is equal to -4. Where do you think x is equal to -4 is going to be? Did you say right here? If you did, congratulations. And let's do one last one. X is equal to 3. Where do you think x is equals to 3 is going to be? Did you say right here? If you did, also congratulations. Ladies and gentlemen, these are linear graphs, straight line graphs on a Cartesian plane. They can either be horizontal, they can even be vertical. But more to that, they can also be diagonal, positively diagonal or negatively diagonal, which we are going to talk about in the next video. So stay tuned as we explore the structure y is equals to mx plus c that governs the orientation and even the position in which these straight lines are going to be in the Cartesian plane. Otherwise, if this stuff is interesting to you, do not forget to subscribe, do not forget to like, and even share with your friends you think they might benefit from this content. Otherwise, this is Mots, your favorite tutor, signing out.